should be somewhat better. It's still getting better, so we're still kind of working on it, but bear with us. I guess that's the time to kick off with Tim and Patrick. Will be just easier to say than that. A wonderful speaker duo. They are amazing, and I'm sure you will love what they have today, I guess. Okay, come on.
All right, hello everyone. Today we're going to take a tour to the Treasure Island. As you can see on this map, we're going through the pebbled sea. There are some stones and some gems. So we'll find treasures, rubies, unicorns, and if you're really lucky, even the infamous disruptor. Let me introduce the tour guides for today. One is this handsome young man, Tim. He's the guy with the ruby multi-threaded concurrency machete. And my name is Patrick. I will sort of have a supportive role in this task. And should you encounter this guy at some point, he's just there to show you important road points on our tour. So don't get irritated. It's actually a really helpful guy or girl. I'm not sure. He wouldn't say. So let's start our talk. The free lunch is over. That was said in 2005. What Mr. Sutter meant here is, if you look at the blue line, I think it should be this one here, all right? So our CPUs are not getting faster as much we want them to get faster. So what CPU vendors did, what also computer vendors did, they started adding more cores to a chip, and I started adding more CPUs to our computers. This one here has 4 cores, the MacBook Air, that we can use. So what do we need to do to make use of them is something called concurrency. So let's talk about concurrency. Giving this morning, it's really easy. It's what this guy said. And I think sometime tomorrow, what this guy is going to say. And from what I hear, also what Yehuda is going to say. So for me, that was a huge relief, because at this point, I could really stop and go, okay, let's go home. Of course, I'm just trolling you, because we're going to take a bit of a different approach here. So let's talk about concurrency, what we want to do, and is multi-core. You want to use multi-core. We want to use all our CPUs, all our cores in our big machines. You can get really cheap 32-core machines these days. So you need something to make use of them. So instead of doing this, I have only one CPU on the other 31, being on holiday, doing nothing, being totally bored, you want to do this. And every time I see this, it gives me goosebumps, because you have 32 cores and they're all fully at work. It's quite effective. What you also want is thread concurrency. So by using threads, your threads will spread over multiple cores. So no cheating by going forking. And so yes, let's talk about the rubies we have available to do that task. So threaded concurrency without forking. One thing you need to look at is the global interpreter lock. That gives you a good hint whether your Ruby is good for what we want to do today or not. And I shamelessly stole this graph from a blog. So this quickly tells you, all right, Emery is out of the picture for what we want to do today, but there is JRuby, which works because it runs on a JVM. There are other Rubies, however. So MRIs are out. Iron Ruby, I'm not particularly sure, because since Microsoft left the project, there are a few commits, but I'm not sure what those guys are doing. Maglev, I have no idea. I haven't checked it. But we have Rubinius, and we have MacRuby, and we have JRuby, who will be up to the task. And today, we're going to focus on JRuby. And so let me take you to Java Island and hand over to your tour guide for the Java Island, the guy with the machete, Tim.
Thanks, Patrick. Yes, so we are going to cover 3 major parts in this talk. And the first one is multi-threading. So, as Jose said, it's sort of has a bad name, right? Multi-threading is not, it's supposed to be messy, it's supposed to be Some might even say it's evil. Don't touch it. Just leave it alone. But I think it's not true. Multithreading is actually very useful. So this is more or less when I wrote this code, and it's really actual production code we use. I mean, I simplified a little bit, but this is code we have in use at Vuga. And when I wrote this code, I fell in love with JRuby, because so the task we had to do is we are processing events, lots of events. We have maybe 100 million events per day, and this will just not do on a single core, right? And by starting the workers as threads in JRuby, you just seamlessly, you don't have to do anything else. You just start a new thread, and then JRuby takes care of the rest. Or actually, the JVM underneath takes care of the rest, of distributing the load across the whole machine. It's very nice. And it's also very simple. Like Jose said, I mean, the main thing to keep in mind is that what's so difficult about multi-threading is shared state. But if you don't have shared state, so in this case, each worker just happily does his own thing, then there's no problem. Then it's super easy, then it's super simple and very powerful. And it's literally in 20 lines of code, you can build a system that handles does this sort of like auto-scaling. And if you would do it without JRuby, or without any of the other Rubies that can scale in this way, you would need something like, okay, now you have separate processes, so you need to put the queue somewhere else. So maybe you introduce the other Redis to keep the queue. But then you have 20 processes to manage. You have to monitor them all, right? So it is much, 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 much simpler. And actually, it is enabled by this thing, so the central structure we use here is a collection from Java util concurrent. And this is also very nice about JRuby, that you have all the goodness that the Java guys have already built there at your fingertips. And it's super easy to use. You just instantiate it like a regular class, like a regular Ruby class, and then you have it. And so the blocking queue, this is where all the work flows in, and where all the workers pull their work off the queue. So this is the only shared state in the whole program, in the whole system. And by just using this array blocking queue, everything is fine, because this already takes care of the whole the semantics that we want. So this is really Java util concurrent. You will have to look into it if you want to do concurrency in JRuby. So it's a pretty big API, but I think it's this is the first treasure chest we can find on Java Island, right? It has lots of good stuff. It has for all the basic types, it has these atomic types that sort of like do auto synchronization. It has other useful things like countdown latches and cyclic barriers. I'm not going to go into the details, but this is just all it's like a tool shop, right? You just walk in and all the tools are there. You still have to learn how to use them. And it's not just the low-level tools that are there, like the cyclic barrier, which is pretty low-level, but on a more abstract level, there's also a whole framework for writing multi-threaded code in a way that is easier to handle and sort of like best practice. So they have this executor framework, also in a standard package, and futures. And it's sort of like executor and future together are sort of like a generic abstraction above concurrency and above thread. So you could, so there's a threaded implementation, and you could switch in other implementations underneath, other executors that do it in a different way. Yeah, and so this is the standard book you have. This is the book I recommend. If you want to do concurrency in Java or in JRuby, this is the book you have to read. It's very good, and it will tell you everything that I cannot put into these 10 minutes now. Okay, and we get to the next part, actors.
All right. So yeah, actors. Obviously, I'm not talking about acting and to be or not to be. I couldn't help but put this slide in again. You got the theory this morning. And thank you, Jose. You did an excellent job explaining it. So I have less work to do, which is amazing. But I will talk about bad actors because I couldn't help with actors and acting and stuff, coming up with what would be bad actors in terms of Rubies again. And there is this Razzie Awards for movies for the worst actor. Of course, with Ruby, it's not that bad. It's just on the scope of what we want to do today. And this one here, if everyone can see it, I was quite surprised. All 3 Jonas Brothers. Is that a whole family? Baddest actor, I was quite surprised. I'm not sure if they won. But in our Ruby land, we have some nominees too. And that was supposed to be a drum roll, but I couldn't come up with a better picture. So, the nominee I came up with is MRI, all MRI implementations for that part, due to the threading concurrency bit I was talking about. You can have actors with MRI, but you can make use the most of it, as you would have with other Ruby versions. So, and more general, what would be better actors in that context? And here's my favorite one, it's Erlang. Erlang is built on top of the very idea with message passing and having actors that do the job for you. It doesn't have any shared state, so it's a perfect fit. And then you have Scala, where it runs on a JVM, which is going to be interesting for us a little bit later. So it has actors built right into the language. It's its way of doing concurrency, at least for doing one bit of concurrency. Rubinius would be a really good candidate for doing it. MacRuby probably, and today, well, again, we're going to go focus on JRuby because this is what we do today. But whenever you start using actors, even though they're a really lightweight form of concurrency, but there's a lot of message passing, there's a lot of chatting, and they're acting up or they're not acting up, you need some way of controlling that. It's like herding cats, so you need to make sure that the communication works and nothing runs astray, right? So you want to use a framework for that. And one you're going to look at today briefly is Akka, which is built on Scala. So we can theoretically use it with JRuby. And there is Celluloid, which is written in Ruby. And it works across all Ruby versions, but you get the most out of it using Rubinius or JRuby. And since we are focusing on JVM today, I'm going to talk about Akka. So if you look at Akka's website, they give you quite a bit of things you can use within one framework. And let's start dissecting Akka a little bit on a very high level. First, it is written in Scala, so actors built right in. I think that's a good start where you go. And Akka itself is heavily inspired by Erlang, at least from where I'm standing. A lot of services that they've built in, and for instance, supervision and fault tolerance and all those things, I know from Erlang, and they seem rather familiar. They just built it on top of Scala, so you can you hurt your actors in a very efficient and fault-tolerant way. Of course, it offers you simple concurrency. This is sort of my DA slide, but you have your simple actors. They give you a simple concurrency. Here's more interesting. It's distributed. So you can talk to actors across physical machines. You have a way of addressing them, and you don't necessarily need to know where they are, which is rather handy. Imagine you need to build that yourself using some queuing mechanism or whatever you need to build to get this job done. And it's also fault tolerant, at least it has it in mind. So because, well, if there's a lot of chatter, things will go wrong, because failure is always an option, especially the more things you add and the more machines, the more communication that's going on, you will have a problem at some point. So it is nice when your framework has that in mind already and gives you tools to deal with that. And something they have are supervisors, which reminds me again to Erlang, what Erlang is doing, and you have supervision trees. So there are super actors that will make sure that the child actors are behaving correctly, and depending on the strategy you gave your supervision actor, it will restart it, it will stop it, it will kill it. So, and if your child actor starts acting up and doing some weird shit, your supervisor actor will make sure it doesn't happen. Sometimes I wish we would have something like that in movies. That you have a super actor that will make sure that some child actors or other actors don't do really silly stuff. And it also might be quite interesting, it's fast, according to what they say. They have a blog post that says 50 million messages per second on a really big machine. I think it's 32 or 64 cores, but it's really impressive the speed they get out of it. And also their memory footprint is rather lowish per actor, the memory you need to allocate to have your actors running, because whenever people hear JVM, they go, oh, memory. So, yeah, it's going to take a lot of memory. It's actually quite efficient in terms of memory consumption. So can it be used with JRuby? Yes, but thing is, I have a confession to make. When I tested this all out, I didn't notice I was using stuff and blog posts and articles that were written in 2010 and 2011. Since then, Akka has moved on, but there haven't been any new stuff being published and using JRuby with the new version of Akka. So in theory, yes, but can you really use it? Honestly, I think you can, but I'm not sure. So now we have covered the actors. We have more for you. Handing back to Tim.
Yes, so now we have gone through two major concurrency paradigms, right? Multi-threading and actors. But, so this is the main point I want you to take away from this talk, is that if you go with JRuby, or if you want to do concurrency, and if you go with JRuby, you do not have to make the decision in advance, right? If you say, okay, I want to do actors and choose Erlang, then you are sort of like stuck on this one model, right? You have to do it in an actor model because Erlang has, for example, no shared memory, so you cannot do anything else. But if you start out with JRuby, then you keep this choice open until very late. So you can sort of like experiment with different approaches, all running in the same JVM. So you can start with multi-threading. You can throw in actors later. You can throw in stuff like STM even, software transactional memory. Because basically everything that compiles to bytecode, to Java bytecode, is accessible and is usable from JRuby. STM, for example, that is based on the Clojure STM implementation. Clojure compiles down to bytecode, so there's a very thin wrapper lib called Cloby by Oliver Nutter, the JRuby guy. And here's an example. So I wrote this bunny class. It's a very simple bunny. It has just two states, or it can be alive or it can be dead. But it's a Clojure object. So let's play around with this bunny a little bit, right? So we make a bunny. Oops. There's one image missing. No, there's not, right? I cannot make a bunny like this. So the thing is about Clojure and software transactional memory, it's all based on references, and references cannot be mutated except in a transaction. So you cannot just go and create a new bunny. That's a mutation, right? You are mutating state. So what you have to do is start a transaction, and inside the transaction, and do sync is just, this is basically the main thing that this Cloby lib implements, apart from the Clojure object, is this do sync method that wraps everything in a transaction, in a Clojure transaction. So now we have a bunny. Nice, cute. But the next thing I'm going to do is going to kill the bunny, brutally kill the bunny, and it's dead. Again, I have to do it in a transaction, right? Otherwise it wouldn't work. Yeah, I'm sorry, I had to do it for science. But we can, okay, so it's really dead, right? If I inspect it, it is still dead. It's not going to get alive again. But we can try again. So let's say we make a new bunny, right? The bunny 2. There it is, alive and healthy. I start a new transaction. Again, I kill the bunny. I'm just that kind of person. No, you cannot kill the bunny. No, don't do it. So, okay, let's run this in a transaction, and what happens is the error bubbles up, right? The exception that I throw bubbles up, and the bunny is still alive. Yeah. So it works very much like a database transaction. So in the end, if it runs through without error, it commits. If there is any kind of exception raised, it is aborted, and everything is the vault is as it was before you started the transaction, and the bunny is still alive. And that is a very powerful thing. And like I said, you can just start a regular Ruby project, and at some point you decide, okay, now I need this transaction thing, and you can just at this point just have it very easily. So it would be, I mean, you could also start the whole thing in Clojure, but it's a much bigger decision to make in the beginning, right? If I start a new project, this time I'm going to do it in Clojure just because I want this STM stuff. It's a pretty big decision to make, right? And there's even more. I mean, now we have multi-threading, actors, software transactional memory. There's also evented stuff that I'm not going to talk about, but there are evented servers that do similar things, like comparable things to Event Machine and Node.js in Java, so they're usable as well. And then there is the disruptor. Patrick. Are we going to talk about the disruptor?
Yes!
So it's very simple. It's very simple. Now, actually, I think the best thing is we show you the disruptor in action, because it's actually not that simple. Just wait a second. I've seen it somewhere.
It's a commercial break. You just...
I hope it was disruptive enough.
So what's this?
Yeah, this is the actual disruptor, but I'm not going to talk about it. It's super interesting. It is, but it would take a whole talk to talk about it. There's a link in the references.
Yeah, it is a super impressive piece of technology. They chose a different approach. They really looked also how queuing system works and decided they were not fast enough. So they found a way to push the limits. So read the paper, it's super impressive technology.
Are you switching to this? Are there any other questions? Are there any other questions?
There's a question over there. Guys?
Josh.
How did you decide that you got to be the ass? yeah, that was pretty difficult actually. So we're both backend developers, right? So that was pretty difficult to decide. But I think if we would have done it the other way around, it would have been a giraffe, not a zebra.
How are you using this at Vuga?
The costume you mean? No, rarely. What else? What else we are using?
Concurrency.
Yeah, we are using the multi-threaded stuff. That's running in production since half a year, and it's working beautifully. I am planning to use the STM stuff for a backend I'm currently building, but I'm not super sure that I will actually in the end use it. Maybe I can just get away without using it. And actors, we have several Erlang projects, but none in JRuby so far.
I'm just curious about Akka. Is Akka using Scala's actor model?
From the code that I've seen, yes.
In the beginning, they had some problems with Scala's actors, and they rolled their own solution or something. It was like late 2010 or maybe early 2011, if I remember well.
Yeah. Honestly, I don't know because I haven't dug through the code. So from what I've seen, it used the same Scala way of using actors, but I don't know if they changed something inside it. So I would need to look it up for you.
And one short question: is the disruptor model close to how React, the database, the NoSQL database, is doing stuff?
Not at all.
No, it's sort of like this ring thing. It's not not a ring in the Dynamo sense, but more like a ring buffer.
Okay, gotcha. Thank you.
All right.
Okay, there's some more links.
Yeah, right. We forgot one more thing. Right, one more thing. We're always looking for good people. So if you want to play around with cool stuff, come join us in Berlin at Vuga.
And they also let you dance in a costume, so.
They also make you dance in a costume. Yeah, the links are there. We will upload the slides, of course. Oops, this one. Those are the 5 really good papers or presentation about concurrency in general and the things we have covered. And the last one is the disruptor. It's a very good introduction of the disruptor.
So thanks, guys. This was amazing. By the way, this all was not at all planned. Don't leave the stage yet. Can we agree, because Vuga was very generous to sponsors tomorrow after party. Can we agree on having a little
well, we can
after show?
Oh, we can bring the zebra, but we can put other people inside.
Yeah, it's actually you can take
Ella, we could put you inside.
I'm sure. So the cool thing is,
Yes.
it was not at all. This is a big incident. I think unicorns are very common in this community, but they would make for a good couple, right? Pink lady, maybe? Okay, and with that, thank you guys. That was amazing performance. And are we ready to welcome Ben? Yeah, here. Sure. Yeah, give big hands.